So every night before I go to bed, I plug up my phone. I use this charger and I put it into the outlet. And then when I wake up in the morning, my phone's at 100%. It's ready to be used. But how did that happen? What's going on behind here? What magic is happening? Let's find out today. Good morning, guys. I'm Mr. Aguilar from Chilhowie Intermediate School, where I teach 3rd grade. Today, we're going to be doing a science activity. This is activity 4 for the summer. Activities and handouts can be found under the Student Resource tab on the Knox County Schools website, www.knoxschools.org. We would love to see what you have learned from today's lesson, and you can show us what you've learned by tweeting at KCS Science. If this video is hard to understand, you can turn on closed captions if available. You can adjust the playback speed to slow down the video. You can consider watching short clips, then pause, listen, and watch again. And you can ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you heard and understand. We're going to spend today's lesson learning about energy, specifically electrical energy. By the end of this lesson, you should be able to answer the question, how does electrical energy affect our lives? Okay, energy. Take a moment and think about that word, energy. What's in your background knowledge about energy? I'll give you a moment to think about that. So as we go through today's lesson and learn about energy, if you have your handout, there will be a few sentences for you to fill in the blanks. Don't worry, it's nothing to stress out over. All the sentences will be in order in the video, and you will see the sentences written on the screen. So all you have to do is fill in the blanks. You ready? Let's get started. Energy is the ability to move something or cause a change in something. Basically, energy is the ability to do work. Think about energy. When I wake up in the morning, I don't have a lot of energy. I'm tired. My students know I need a lot of Diet Coke full of caffeine to get energy. But did you know there are different forms of energy? Let's look at 5 of the most common forms of energy. One type of energy is heat energy. Heat energy is matter that is made of small moving particles. The energy of these particles is heat energy, and heat energy moves from warm objects to cooler objects. Time to start cooking. Another type of energy is sound energy. This is my favorite energy because I'm a musician, so I love to listen to music. But how do I hear that music? How do I hear the sound? Well, I hear it through sound energy. Sound energy is a form of energy you can hear. Sound moves in waves through matter such as air or water. A third type of energy is chemical energy. Chemical energy is stored energy. There's stored energy in oil, gasoline, coal, matches, wood, and food. Yeah, food. Chemical energy is released during a chemical reaction. Energy from the power of tacos. A fourth kind of energy is light energy. Light energy is energy you can see. It moves from place to place in waves. Light energy can come from the sun, obviously the sun, lamps, flashlights, fire, and many other sources. And light energy can come in many colors too. A fifth kind of energy is electrical energy, and this is the type of energy we're going to spend today's lesson on. Electrical energy. Well, what is electrical energy? Electrical energy is an energy of moving charged particles. Well, what are particles, right? Particles are the tiny building blocks that make up matter. Lightning that you would see in a storm. Lightning is the movement of charged particles in nature. Electrical appliances use electrical energy that moves through wires. Here's a picture of an electrical engineer. Take a moment and look at it. What do you notice and wonder about this picture of an electrical engineer? Well, I notice there's a young man in what looks like a science lab, and I see computers, and I see wires, and I see he has on his safety goggles so he doesn't hurt his eyes, and I see he's trying to do something with those wires. So I wonder, what is he doing in that lab? Why are there those computer-looking things? What are those wires? Why are they different color? What is he doing? What does an electrical engineer do? Let's find out. Electrical engineers design and build circuits or electrical devices. An electrical engineer might work on computers, robots, phones, and medical equipment. If we're going to be electrical engineers today, we need to be able to talk like an electrical engineer. So let's look at some vocabulary words that electrical engineers would know. The first one is circuits. What is a circuit? Well, a circuit is a path that is made of parts that work together to allow current to flow. And we're going to talk about that later. Electrical engineers also know what a charged particle is. A charged particle is particles that have either a positive or a negative charge. An electric current, what is that? An electric current is a flow of charged particles. And later we're going to experiment with an electric current. So obviously if you're an electrical engineer, you must work with electricity, right? Well, what is electricity? What's in your background knowledge when you hear that word electricity? Take a moment and think about that. What is electricity? Well, electricity is energy that's caused by the movement of electrons through matter. So here's an example of electrical engineering affecting your lives. If you look here, you see that there are some cables that are connected to my house. These cables start over at that electrical pole, and if you look up toward the top, you'll see the transformer. And inside of that transformer, there's a bunch of energy stored. And then through the wires, an electric current flows, goes into my house, and that's how I'm able to get the power to turn on my TV, my computer, all the other electrical devices. Wait a minute. Hold on a second. Why is there red lights? Something's wrong with my... Is this on? Hello? My camera ran out of electricity. Sorry about that, guys. I don't know what I would have done if I didn't have electricity to use in my house. You know what that makes me think of, actually? Think back to the beginning of 3rd grade. Do you remember in reading class, we read a story called When Charlie McButton Loses Power? I almost had to go through what Charlie McButton went through. Maybe you're thinking I don't remember that story, or maybe you didn't read it at the beginning of the year. If you didn't, let me summarize it for you because it's a great book. Well, at the beginning of Charlie McButton, there's this boy, Charlie McButton, and he loves to use technology. The only thing he wants to do is use technology. He wants to play his video games, he wants to be on his computer, he wants to be on his devices. The only thing that Charlie McButton wants to do is stuff that requires electricity. But then one day, there's a power outage at his house, and everything in his house turns off. Charlie doesn't know what to do, because the only thing he wants to do is stuff with electricity. And he is mad. He doesn't know what to do. Well, maybe Charlie McButton needs to think like an electrical engineer. If you haven't read this book before, I really recommend you go to the library or check it out somehow and finish it to see what he does. But we're going to think about how to be like an electrical engineer to solve a problem if we were in a power outage. So what is a power outage? What causes a power outage to happen? Well, let's back up. Let's not get too ahead of ourselves. Before we learn what a power outage is and what causes it to happen, we need to learn how do we get power in the first place? Where does power come from? Circuits allow electricity to travel through it. So in our house, we have things we want to turn on. We want to power up, right? Maybe you want to turn on the TV to play a video game. Maybe you want to turn on your computer. Maybe you want to turn on a light that has a light bulb. You can't just go up to the light bulb and say, turn on, light up, right? It doesn't have stored energy inside of it. It's just a light bulb. How do I get this light bulb to turn on? Well, I need to find something that has energy already stored up inside of it. Maybe like a battery. A battery has energy stored up inside of it. But I can't just put the battery to the light bulb and expect the light bulb to turn on. I need to find a conductor of energy. Now you might be thinking, what is a conductor? Like a conductor of a train? Not quite. A conductor of an orchestra? No, not that kind of a conductor. We're talking about a conductor of energy. A conductor of energy allows energy to travel through it. So one of the most popular forms of a conductor is a cable. I'm sure you have tons of cables inside of your house. These cables are conductors that allow electricity to travel through it. If you were to open up this cable and look inside of it, you would see metal wires going all the way through this, which allows the electricity to travel through it. So if I want to turn on the light bulb, I have to find the source of energy, maybe a battery, maybe the outlet in your house, plug a cable into it, into the lamp or into the light bulb, and the electricity will go through the conductor and turn the light bulb on. And that's how we get power. But sometimes there's a disruption to that flow. So think about those wires I showed you that are outside of my house that connect to my house. Those are circuits. Electricity is traveling through them to bring electricity into my house. But what were to happen, and I'm sure this has happened to you at your house at some point, what if a tree crashed into those wires and knocked the wires out? Or what if there was a hungry little squirrel that decides to start nibbling and nibbles too much on those wires? What would happen then? Well, guess what? That's what causes a power outage. It's a disruption in the flow of energy through the circuits. Think about a time when there was a power outage in your house. Hopefully it wasn't at night. I know this happened to me when the power just goes out and I am sitting in the dark in my house. What? So, although power outages are annoying, they're not the end of the world, right? We've all survived a power outage. I know that the last time I had a power outage, thankfully, a couple hours later, some people came and worked on the power lines outside of my house, and they were able to turn the power back on. So the electricity was able to travel through the wires that they had just fixed and come back into my house. Or think about your car. Have you ever had your car not start because the engine won't work? Maybe you've had to help jumpstart your car, or someone's had to jumpstart your car. That's getting the electricity from one car into another car through those cables, through that conductor. All right, let's become electrical engineers and do a science activity. I love science activities, don't you? Before we begin, let's review the design process. What is the design process? Well, there are steps to the design process. We need to identify a problem. Maybe the problem is you've had a power outage in your house. Well, after we identify a problem, we need to develop a solution. How can we possibly fix this problem? Then we need to choose a solution. What's the best solution to use? Then we want to build a prototype. Prototype? What's a prototype? A prototype is basically an attempt at what you're trying to create. Then we want to test that prototype. Does it work? That's when we're really going to do that science experiment. And then we want to make a final design and communicate the results. So we're going to share what the results were. And based off of what those results are, we might want to identify another problem and then start the design process over again. Okay, so let's do a science experiment. Let's become electrical engineers. We know that engineers use science to solve problems. So we're going to say our problem is we're in our house and there's a power outage. There's no light in our house. We're sitting in darkness. You don't have candles. You don't have a working flashlight. What are you going to do? Let's think of a solution. Well, let's use some materials in our house that we could use to create light. So here's what you need for this activity. You need aluminum foil, 2 batteries, an LED light bulb. Electrical tape and scissors is optional, but you might want to use it. So you might be thinking, what are LED light bulbs? How do I get them? Well, if you have Christmas lights use LED light bulbs. So with your parents' permission, maybe you can carefully pull one of those off. Or you can do what I'm doing. I have these tea lights that I got from the Dollar Tree. So I'm just going to get this one. I'm going to open up the back and pull out the LED light bulb. So now I have a light bulb to use with this experiment. If you have the handout, these materials in the directions for the activity are listed in the handout. Okay, so let's get started. What we're going to do is use our 2 batteries and our light bulb and our aluminum foil to turn on the light. Well, take a moment and think about that. How are we going to use these materials to make this light bulb come on, to power on? Take a moment and think about that. In your handout, there's a space at the bottom of the first page where you can write down your hypothesis. What is your hypothesis? How are we going to use these materials to make the light bulb power on? I'll give you a moment to fill that out. So I'm going to get my aluminum foil and I'm going to, I need 2 strips of it, and what you're going to do is you're going to crumble these up until you have 2 wires. Because remember we talked about circuits before and we can use cables, so you're making basically a cable with your aluminum foil. So when you're done, you have your 2 cables, aluminum cables we can call them. You're going to put those down. Now what you need to do is get your batteries. You're going to set them down. You need to put them in a specific way or else this won't work. We know that batteries have a positive end and a negative end. The positive has like the plus sign, the negative has the minus sign. When we put these down, we want to make sure that we have the positive side touching the negative side. We're going to put them down side by side. So now let's get our aluminum foil cables that we made. Here's where if you have electric tape, it's going to really come in to help you. If you don't have electric tape, that's okay. You just have to hold them very carefully, tightly, or if you are working with your parent, you can have your parent press them together. So what I'm going to do is get my cables and I'm going to go over to this one, and at the negative end, I'm going to put the aluminum foil right as close to the middle as I can. I'm going to tape it. And I'm going to go with my other battery. I'm going to go to the end where the positive side is, and I'm going to make sure that I put this aluminum foil at the center of the part that sticks up. Tape that down. Remember, if you don't have electric tape, you just have to press it down, or whoever your assistant has to press that down. And then once that's done, I'm going to get my batteries. I'm going to make sure that the positive end is touching the negative end, set those down, and I'm going to have the aluminum cables up at the top kind of come together. You don't want them to touch, but come close together. And then if this is done correctly, the light bulb should come on. So on your LED light bulb, there should be 2 wires coming out. The wire that's sticking out to the right is going to touch the aluminum foil on the right, and the wire sticking out to the left will touch the aluminum foil to the left. Let's see if it comes on when I touch them. Oh man, didn't come on. That's okay, because I'm thinking like an engineer, like a scientist. I know that I have to have a growth mindset about science experiments, right? Well, this makes me think of something we read about in 3rd grade in our sleuth book, and an article called Don't Give Up. I definitely don't want to give up after the first try. Did you know that the man who invented the light bulb was called Thomas Edison? In this article, Don't Give Up, it says that Thomas Edison didn't give up. He invented many things, including a long-lasting light bulb. It took him hundreds of tries before he found the materials that worked best for his invention. He never thought of himself as a failure. He said, I have not failed. I have just found 10,000 ways that don't work. Every time Edison tried something that didn't work, he got one step closer to finding a way that would work. So I just found one way that didn't work, so I just have to make some revisions to my experiment and see if I can get the light to turn on. So before, what I did was I just set these side by side and I tried touching it, didn't work. What if I were to squeeze the ends of the batteries? You can see. So I'm going to squeeze the ends of the battery. See if that will help the electricity flow a little bit better. Alright, wish me luck. What do you notice? The light bulb is coming on. Can you see? It worked! I made a circuit. The energy that's stored in the batteries is flowing through my aluminum cables that I created and is making the light bulb come on. I was just being an electrical engineer. Did it work for you? On the bottom of page 2 in your handout, you'll see a place where you can write a narrative. In this space, you can write a narrative, which is a story, about a time when there was a power outage in your house. Explain, like an electrical engineer, what caused the power outage. Describe how you created energy in your house while you waited for the electrician to fix the power outage. So before we go, let's review what we've talked about. We have learned how electrical engineers affect our lives. Electrical engineers have to think of ways to create circuits. What does that mean? They have to find a way to get something that has stored energy and create a pathway for the energy, the electricity to travel to power up something else, like a light bulb that you just did. Thank you so much for watching, guys. I hope you had a great time. I especially want to say a big shout out to all the Chilhowie Eagles, especially my Team Iowa members. I miss you guys. I hope you all had fun. If you did the light bulb activity, I would love to see what you did. You can tweet us at KCS Science. Thanks, guys. Have a great day. Bye.